Here we're going to be looking at a few examples of how to solve a system of linear equations by substitution. So substitution means that what we're going to be doing is noticing that we know that y equals negative 6x plus 8. Okay, this equal sign is telling us that y and negative 6x plus 8 are exactly the same. So they're completely equal to each other. What that means is that we can now substitute into the second equation. Instead of using y in the second equation, instead I'm going to use negative 6x plus 8 because they are completely equal to each other. Instead of y, negative 6x plus 8. And now we'll have this equation written with only one variable, and that'll make it possible for us to solve it. So let's go ahead and get started. We're going to rewrite the second equation. 4x equals, now instead of y, remember we're going to substitute the expression that we know is equal to y, so negative 6x plus 8. Okay, so that's y. And now we're going to subtract 12. Well, there's no need to use the distributive property here, so we can just write minus 12. All right, now I want to solve this. I've got only x's in this equation, so I'm going to get the x's onto the same side. We're going to add 6x to both sides. So now I know that 10x equals positive 8 minus 12, which is negative 4. And when I divide both sides by 10, I now have x equals negative 2/5. Simplified 4/10. So we have an x value of negative 2/5 here, x value of negative 2/5 here. We just have to figure out what our y value is going to be. If we look at choice C, it says no solution. And remember, we have a couple of examples in our OMG of no solution. We have one example anyway. When you do the algebra and you get down here, you're going to get something that's not true. So maybe you'll end up with 3 equals 5, which you realize is clearly not true. Or negative 2 equals positive 2, which is not true. So if you get a false statement, then you would have to say that there is no solution, because that's telling you there's no place, no point on the coordinate plane that you can be that satisfies both of these equations at the same time. Therefore, you know that if you solved for their slope, you'd realize that they have the same slope. They're parallel lines. That's why they have no solution. Okay, so if we go back to the graphing, that's what we're thinking about there. In infinitely many solutions, if we were graphing, would look like two lines that are actually the exact same line. So they look different in the two different forms, but then when we get them into y equals mx plus b form, we realize they're actually the same line. Well, with algebra, we would have infinitely many solutions if when we get to the end of our algebra, we realize that we have something like 3 equals 3, which is true. Or negative 7 equals negative 7. Or even 0 equals 0. Maybe all the variables cancel out, all the numbers cancel out, you end up with absolutely nothing on each side. 0 equals 0. Well, all of those are true statements. Therefore, we would choose infinitely many solutions. There's not one specific solution. There are tons of them. All right, so back to this problem. We know it's either A or B, but we have to figure out what the y value would be when x equals negative 2/5. So now we're going to take that x value of negative 2/5 and we're just going to plug it back in to the equation, and then we can calculate or figure out what y equals. We really could use either equation. I'm going to go ahead and use the first one. It doesn't matter which one you use. So we have y equals negative 6 times x. So we're going to do negative 6 times x, which is negative 2/5. Okay, so there's negative 6 times x, and then we're going to add 8. add 8. All right, so now we know that y equals, let's see, negative 6 could be over 1. So negative 6 times negative 2 is positive 12 over 1 times 5. And then we're going to add 8. All right, well, if I'm fairly confident in my work here, I can pretty much at this point choose B. Because if I take a positive number and I add 8, I'm definitely going to have something more than 5 3/5. Or we could realize that 12/5 is actually 2 2/5. And when you add 8, 2 plus 8 is 10, plus your 2/5. So yes, now we can say for sure that 10 2/5 is the y value. So we are very confident in choosing B. All right, let's take a look at another example. Okay, remember, we're trying to use substitution. Okay, so let's look at, we now see that y, in this case, we're solved for y, so y equals negative 7x plus 1/2. So what I can do is substitute this into this equation instead of the y. Okay, so I'm going to rewrite the second equation. Negative 6x equals y, which is negative 7x plus 12. I'm sorry, plus 1/2. And then I'm going to add, that was the value of y, right? All of that was y. And I'm going to add 1/2. 1/2. Okay, so these fractions were really scaring me at the beginning. But now I'm realizing that, let's see if we're just going to add 7x to both sides to bring that over here. And now 7x minus 6x is just 1x. And here's what I'm realizing. 1/2 plus 1/2, well, that's easy. 1/2 plus another half is 2. So our x value is 2. This has the wrong x value. This has the wrong x value. This one's good. And that one's good. So now we're going to have to go back in and figure out what our y value is. So I'm going to use this first equation. Remember, you could use either equation. It really doesn't matter. But since I want to find y, this one's kind of set up nicely. Y equals negative 7 times x, which is 2, and then plus 1/2. So y equals negative 14 plus 1/2. If you're confident with integers, you'll realize that if you're at negative 14 and you add a 1/2, you're getting closer to 0. So you're at negative 13.5. If you're not that confident with integers, use a calculator. Negative 14 plus 0.5, you'll get negative 13.5. So now we know we're looking for this y value. So we want to choose D. Okay, so don't let those fractions scare you. Usually in this objective, they're going to work out to be something that's completely manageable. All right, here's another example. Now we can use, they're telling us to try to use substitution. So I know that I can use substitution if I figure out what one of my variables equals. I need to solve for one of my variables. This one looks easy to solve for. Okay, I know that y, if I subtract 5x from each side, I'm just going to do that right here, y equals 21 minus 5x. Okay, so now I'm going to use, and yes, this one is a little bit ugly. They've got big numbers in here. You have a calculator. You're going to be fine. So I'm going to take 21 minus 5x and substitute it in for y in this first equation. So we have 25x plus, now this time we're doing 6 times y. So 6 times all that stuff. So 6 times 21 minus 5x equals 91. 25x plus 6 times y equals 91. And now we can solve. So 25x, I'm going to have to distribute here. So we get positive 126, and then we get negative 30x equals 91. Okay, we're going to combine like terms. So we have 25x minus 30x gives me negative 5x. And if I subtract 126 from each side, maybe I should have subtracted 91. Okay, you know what? I'm going to go back, because you can always change your mind when you're working. I realize that 25x and negative 30x give me negative 5x. But I want to add that to the other side, so I can have a positive 5x. I'm going to subtract 91 from both sides. If I do this, I won't have to bother to get out my calculator. This will make the mental math a whole lot easier. We get 5 and 3. 126 minus 91 is 35. Who needs calculators? 91 minus 91 cancels out, and I have positive 5x. So that means that x equals 7 when I divide both sides by 5. All right, so we need an x value of 7. I got it here. Not there. Not there. That's a y value of 7. And that's also an x value of 7. So we are going to have to go back and find y. So let me use this equation. Remember when I subtracted 5x from both sides so that I created y equals 21 minus 5 times x. Well, 5 times 7 is 35. So 21 minus 35. Y equals negative 14. That means we want A. Okay? We have a couple more examples for you. All right, we're not going to do the whole thing on these. You guys are really good at doing the algebra. I just want to show you how to get started, and then you can always finish them up on your own. Okay, here's a nice example. Here's something that I wanted you to look at. Yes, we could take this first one and we could solve it for y. Okay, we could minus 1/2 x from both sides. I want to look at a couple of options that you've got, though. You could also say, you know what, I don't like fractions. I want to multiply everything by 2 because I would really like to get rid of the fractions. So 2 times 1/2 is 1, so it gives me 1x plus 2y equals, see, 2 times 40 is 80. Now, if I solve for x, I could just subtract 2y from both sides. So now I know that x equals 80 minus 2y. I could take that and substitute into the other equation, and then I could solve for y. Okay. Another thing that we might want to notice was that with this particular example is that all of the numbers in this equation are divisible by 20. 20x plus 20y equals 20, which really means that x, 1x, plus 1y equals 1. Well, that's a lot easier to deal with than that equation. So now I have two equations, x equals 80 minus 2y, and x plus y equals 1. So I'm going to take this x, 80 minus 2y, and I'm going to substitute it in for the value of x over here. Okay, so we have 80 minus 2y. There's our x, and now we're going to add y, and that has to equal 1. Okay, you can finish up the algebra by yourself. You know how to do that. Let's look at something interesting with the next example. This one says that y equals x. So they're right away telling me, hey, wherever you have a y, you can just replace it with an x. Or wherever you have an x, you can replace it with a y. So I could say, okay, -5, and since y equals x, I could just write an x instead. Remember, they're twins. Doesn't matter who shows up. Nobody's going to know the difference. And we have -4 and then minus. Remember, I'm writing this one in terms of x, so I'm just going to go ahead and leave that in x. Now I have only one variable. Okay, all I have to do is add 5x to both sides, add 4 to both sides, or any, you've got other options, you know that. Whoops. All right, those cancel, so now that we know that 4 equals 5x minus x, which is 4x, so x equals 1, and there we go. I said I wasn't actually going to solve these, and then I went ahead and did some anyway. So we have to plug that one. Oh, wait a minute. We know that y equals x. So if x equals 1, we also know that y equals 1. So that means that I definitely want to choose A. And it actually means that since y equals x, this was never going to be okay. That x does not equal the y. And this one was never going to be okay because x and y are not equal. So we could have eliminated those just by looking at our first equation. All right, the last one I wanted to look at with you. Remember, I know you guys aren't completely in love with fractions. So if you don't want to take 1/8 y and plug it in for x, you do have other options. It's really not so bad, though, so let's look at it. I'm going to take x, and I'm going to replace it with 1/8 y. So let's rewrite this first equation. We get y equals 32 times x. And remember that x is 1/8 times y. So I have 32 times 1/8 times y. And now I want to subtract 4. So 32x minus 4. Okay. No need to panic. 32 times 1/8 really means we want 1/8 of 32, which is 4. Or we could put a 1 under here. 32 times 1 is 32. 1 times 8 is 8. Don't forget your times y. We're going to subtract 4. And then we realize, oh yeah, okay, no reason to be scared of these fractions. 32 divided by 8 is really just 4. So I have y equals 4y minus 4. And now I can continue to solve for y. Subtract y from this side, add y, whatever you want to do. Okay, add 4, subtract 4y from both sides. You've got a bunch of options, but I know that you can solve that. So hopefully that helped you with some of the slightly more difficult aspects of the substitution method.